x is equal to 1, or I'm sorry, whole when x is equal to 0. And if I cross out the 5, then we would fill in that hole with a y value of 1. But with that 5, then this hole is up here at y is equal to 5 instead of y equals 1. Now, today we're not interested in that hole in this particular graph. We're interested in the end properties of this function. Okay, so what's happening to this function as x gets really large? And so right now, I'm looking at x values from negative 10 to positive 10. And if we are interested in the limit as x approaches infinity of 5 times the sine of x over x, then what we might want to do is to readjust our graph. So for example, I don't care at all about negative x values, but I do care about large positive x values. So I might change my window here for an x minimum of 0, and maybe an x maximum. Let's take a look at 50 and see what happens. Well, it kind of got eaten up by the x-axis, so I'm going to change my y values there. Maybe I'll change my window from a y minimum of negative 5 to a y maximum of positive 5. Still kind of got sucked into our x-axis. So as x gets very large, our function is somehow being dampened down and getting, the amplitude of this function is getting smaller and smaller and smaller until eventually it just gets eaten up by the x-axis. And right now we've gone from x values from 0 to 50, but I can change this and make my x values 0 to 100, and this is going to make this even more extreme. Oh, it's totally gone now. It's going on in here, but my calculator can't even deal with the motion. There's hardly any motion going on. Function is still oscillating, just very itty-bitty little bit of oscillation going on. And so because this is happening, because our function is approaching our x-axis, approaching a y value of 0, as x gets really big, we say that the limit as x approaches infinity of 5 times the sine of x over x is equal to 0. Now, here is an example. This function continues to oscillate back and forth, up and down, above and below the x-axis, forever and ever and ever. Infinitely many times, this graph goes up and down and crosses that x-axis. So while y equals 0 is a horizontal asymptote, our function is crossing that horizontal asymptote infinitely many times. And that's totally legitimate. Okay. Any questions about that example?
So goof around with the 5 sine x over x. Couldn't that be written as 5 times the limit of sine x over x?
So if we were rewriting this guy, we could certainly bring that 5 out in front.
Am I correct in remembering that sine x over x equals 1?
When we take the limit as x approaches 0.
Oh,
So in this case, our x value is approaching infinity. So something to think about this, even if I move this 5 out in front and I have sine x over x, that top number, the sine function never gets larger than 1, never gets smaller than negative 1. And so the numerator of our function is bouncing back and forth between positive and negative 1. Our denominator is getting larger and larger and larger. So even if we take the biggest value that our numerator can be, which is 1, if our denominator is a bajillion, if you have a bajillion people standing in a room and you have 1 pizza to divide among them, how much pizza is each person going to get?
One bajillion.
You're going to have a lot of hungry people on your hands. Because if you take 1 pizza and divide it among a bajillion people, each person's going to get a little slice of pizza that's going to be so small that they won't even be able to taste it. And so it would make sense that this value, our numerator is bouncing back and forth between plus and minus 1, and our denominator is growing huge. Okay, so the whole fraction is getting very small. Okay, so some things to think about. But let's stop here. We'll take a 10-minute break. When we come back, we're actually going to address Will's question about the algebra of what's going on.